In this video, we're going to do some extra examples where we use both the quotient and the product rule together. Okay, so these can be simplified to avoid this, but just for practice for now, we're going to try it this way. So for part A, f of x, we have 2x plus 1 times 3x squared minus 5. So I have a product in the top and another polynomial in the bottom. Okay, so it's a quotient rule, but the derivative of the top is also a product rule. Now remember, like I said, you could FOIL this out and then avoid the product rule. Okay, but sometimes we won't be able to do that. But that's when we have the chain rule. So for now, we're kind of stuck with this, but just for practice, we're going to try it this way. So let's compute the derivative of the top first. Okay, so that's using the product rule. So it's going to be this first function times the second function. So the derivative of the first function is just 2 times the second function as it was, plus the derivative of the second function, which is 6x, times the first function as it was. So if I simplify this, it's going to be 6x squared minus 10 plus 12x squared plus 6x. So if I put the x squareds together, it's 18x squared plus 6x minus 10. So that's the derivative of the top. So now when we use the quotient rule, so f prime of x, I'm going to do the derivative of the top first. So that's what I just did. 18x squared plus 6x minus 10 times the bottom as it was, minus the derivative of the bottom, which is just minus 4, times the top as it was. Oops. This is a minus 5. And then that's all over the bottom squared. Okay, so now I'm going to have to expand all this out. Okay, so I have to take each of these terms and multiply it to both things in the bracket here. So I'm going to have 18x squared minus 4 times 18 is 72. So it's going to be 72x cubed plus 6x minus 24x squared minus 10 plus 40x. And then I'm going to have plus 4, and I have to expand these brackets out. So that's 6x cubed minus 10x plus 3x squared minus 5 all over 1 minus 4x all squared. So I want to look for like terms here. So I see that I have x squared here, and an x squared here. Now remember that this 4 still has to go to everything in here too. So we don't want to forget that. But in total, we're going to have 18 minus 24 plus 12. So that's 6x squareds. Okay, I see an x cubed here and an x cubed here. So there's 72, negative 72 plus 24. So that's going to be negative 48x cubed. Okay, now I have x's in a bunch of spots. So I have 6x plus 40x and then minus, that's x, minus 40x. So I actually am going to have plus 6x. And then finally, I have a negative 10, and then the 5 was actually negative 20. So I'm going to get negative 30 there. And this is all over 1 minus 4x all squared. And if we want, we could actually factor out a 6. So it's going to be x squared minus minus 8x cubed plus x minus 5 all over 1 minus 4x all squared. So that's probably how we'd want to leave our derivative. Okay, one more. So this time, let's do the derivative of the top and the derivative of the bottom. So the top is 2 times x to the 1/2. So it's going to be 2 times 1/2 x to the minus 1/2. So that's just x to the minus 1/2. And the derivative of the bottom, we're going to want to use the product rule. So the derivative of the first function is 2x times the second function plus. Derivative of the second function is just 3 times the first function. So if I simplify, this is 2x plus 6x squared plus 3x squared minus 12. So we get 9x squared plus 2x minus 12. Okay, now we're going to put all this together. So the derivative, g prime of x, is the derivative of the top. So x to the negative 1/2 times the bottom. Okay, minus the derivative of the bottom times the top. Okay, all over the bottom squared. Okay, so we need to expand all this out. So I'm going to leave the x to the negative 1/2 and expand the rest here. So that's going to be x squared plus 3x cubed minus 4 minus 12x. And then over here, now maybe I should have written square root of x as x to the 1/2, so that when I expand it in, it makes a bit more sense. I can put the exponents together. So it's going to be minus 18 x to the 5 over 2 minus 4 x to the 3 over 2, and then plus 24 x to the 1/2. Okay, and all of this is over x squared minus 4 squared times 1 plus 3x squared. Okay, now I'm going to move this one in as well. So that's x to the 3 over 2 plus 3x to the 5 over 2 minus 4x to the negative 1 over 2 minus 12x to the 1/2. And then I have all of these other ones that we already found. Okay, and now I just want to put like terms together. Okay, so I see x to the 3 over 2, I have a few of those. X to the 5 over 2, I have some of those. And, x to the 1 over 2, I have some of those in common. So, it's going to be negative 3 x to the 3 over 2 minus 15 x to the 5 over 2 plus 12 x to the 1 over 2 minus 4 x to the negative 1 over 2 all over x squared minus 4 all squared 1 plus 3x all squared. Now we shouldn't really leave negative exponents, so maybe we want to factor out x to the negative 1/2 here. So then I'm going to have negative 3x squared. minus 15x cubed plus 12x minus 4 over the bottom. Okay, and then because it's negative, it actually can drop to the bottom now. So I'm going to have negative 3x squared minus 15x to the 3 minus 12x minus 4 all over square root of x times x squared minus 4 all squared, 1 plus 3x all squared. So here would be our derivative in a simplified form.